Hey guys, so today we're going to talk about shapes of distributions. Now, we kind of talked a little bit about that with box plots when we talked about skewed left, skewed right, and symmetric. But today we're going to talk about those situations when we're talking about a histogram. So a histogram, you've probably called it a bar graph before or a frequency table, or not like a table, but a frequency graph. All it is it's showing you that in whatever data set you're using, if I'm going from 1 to 8, I had 5 data points. Or if I'm going from 25 to 32, I'd say I'd have 25 data points, okay? So this is what a histogram does. It might not show you exactly what the data is, but it represents it in a way that shows a little, like, how the distribution is working instead of just looking at the numbers and being like, okay, well, I have no idea, right? So a frequency table kind of helps us make those distributions. Now, if we're talking about a frequency table or like a histogram here, we still have skewed left, skewed right, and symmetric. So I'm going to put those up here. If your frequency table or your histogram looks like this, where it's got this long tail on the left side of the graph, what this is it's skewed left. It's saying I need to push the highest one to the left to make it symmetric, right? Okay, so same thing goes with skewed right. If I'm talking about the right, it has that tail over here on the right side. It means that more of the data is on the left side of the graph, so I need to push that data towards the left to make it in the middle. Okay, symmetric is really what we go for. That's the one that's called a normal curve. That's what I wrote down here. We'll talk more about that tomorrow and why data that uses symmetric or distributions or normal curves give us a lot more, we can get a lot more statistics from that than we can if it's skewed left or right. But yeah, that'll be more to come. So an example of something that's symmetric, I would say, is probably height, right? We would say like the average height would be this. There's a few people who are a lot taller. There are a few people who are a lot shorter. But for the most part, symmetric distribution, that would work with height. An example of skewed left might be your guys' grades, right? We have a lot less people failing than we have A's. So skewed left might be something like that. This one, I would say skewed right. Okay, well, we could do like potty training for little kids. The younger you are, the more people you're like, maybe when they hit 2, you start potty training, and by the time they're like 4 or 5, you should probably have that under control. Maybe not, we'll see, but like something like that would be an example of skewed right. Can you tell I'm hanging out with my cousins so much that babysitting that I've got going towards potty training as an example for high schoolers? Wow, I'm sorry guys. Maybe that was funny at least. Okay, but this is the idea. A frequency table shows the number of raffle tickets sold by students in your grade. Display a histogram and describe the shape of distribution. Okay, so this is what I would be giving you. I'd be giving you like a table here, and you'd have to fill in those values in a histogram. I went and did that. So we've got this. This is the one that I used at the very beginning of this video. But this would be our histogram, right? If I was basing it off of these data points, these number sets that's given, right? So if I was talking about this and saying, okay, this is shape of this distribution, I would say, well, I could say, well, maybe this needs to go a little over here. So I could be really picky about it and say this was slightly skewed to the left because I need to push it to the left. But really, honestly, I think this is pretty symmetric, so I would write symmetric. Because this middle is here, and it does kind of follow this like normal curve, this bell curve kind of thing, right? So I'd say this is symmetric. So if I gave you a frequency table like this, again, you just fill in your frequencies. You want to make sure that you have those intervals at the bottom, and on the side you'd want to probably go up by 5s because this is pretty nicely organized like that. If I delete this, this is what this frequency table looks like. I can definitely tell there's a tail here. And this would need to get pushed to the left. So this one is definitely skewed left. What this means is that more of the cans were higher than what you'd expect, right? You'd say, okay, well, this is skewed left. There's a higher number of pounds than what was brought in from the 0 to 10, okay? Now, why does this even matter? This shape allows us to choose an appropriate measure of center, okay? And if we have an appropriate measure of center, we might know what our variation should be. Okay, so if it is symmetric, what that means is that the mean and the median are very similar, okay? What you would use is you'd use the mean, and with mean goes standard deviation. If that's the only thing you get from here, from this section, is that mean is always with standard deviation, that's going to be your big takeaway from the stats portion that we're doing online, okay? Mean and standard deviation. Now, if it's skewed, what that represents or what that signifies is that if it's skewed to the left, means that the mean is lower or should be lower than the median, okay? If it's skewed to the right, it means that the mean is actually higher than the median. So with these two sections, if it's skewed, you're going to want to use median because we can't find that standard deviation is going to be way too wide. It's not going to show us it's not going to tell us a lot of good information. Okay, so that's why we have to use this when it's symmetric, which allows us to use the mean. And we need to know that because the standard deviation is created by the mean. Okay, so if you're using a median, that's when you're going to want to use your 5-number summary, or when we're talking about that, our box plot points. Okay, that's where your big 5-number summary goes from, median. So if you think median, you should honestly think IQR and range. That's that other big takeaway. So your really big takeaways from this section, at least, is if you choose mean, if it's normal, you should choose standard deviation as a variation. And if you have to choose median because it's skewed in some way, you have to use range and IQR. Those are like the big things that I want you to get from here. Okay? Those are the ones that work together. Oh, dang, I didn't put a thing on here. All right, so a police officer measures the speed of 30 motorists and shows the results in this table. So here's his table. He tracked down all of the speeds. It said, describe the data in histogram using 6 intervals beginning with 31 to 35. So what it's saying is I want to break these numbers up into 6 different sections, starting with 31 to 35. So I'm saying, okay, well, that's 5 numbers. So I want to make sure that they're even. Each one of these have 5. So that's where they're getting those numbers from. And then we just count. So if I'm looking for 31 to 35, I've got 1 here in this list, and I've got 31 to 35. Do I have another one? I can't find another one. Okay, that makes sense. That's why there's only 1 here, right? It only went up to 1 on the frequency. Now, if I was talking about the next one, 36 to 40, I'm looking down this row, and I've got nothing in the first row. I've got 1 here. I've got 2 here. And do I have a third one? Because it looks like, oh yeah, I've got 40 down here. So that's 3. So that's why this one is at 3. Okay, so that's how you're getting these numbers. You just look through the data and put those numbers there. I will have you make a frequency table at least something that looks like this one in the program, because I can't have you actually make a graph, but it might be helpful for you to see the distribution if you at least draw the lines, right? You can say, okay, well, this is 5, 9, 16, 25, 28, 7. Might help you a little bit see how that distribution is being distributed, or how the shape is going to look. Okay, so back to this one. That's how we get these numbers. The second one, it says, which measure of center and variation represent the data? So what I would do is I'd say, okay, well, what does my shape look like? How is this going? Okay, well, I definitely need to push this over to the left because it's not centered. So I'm going to say I have to use the median here. It's not centered. The mean is not a good representation. So I'd say the median and the 5-number summary. Right? Now my last question here was, the speed limit is 45 miles an hour. How would you interpret these results? So what I would do is I'd say, okay, well, this is 45 miles an hour right here, this red line that I'm making, 45 miles an hour. What would I say? I would say for this case, a lot more people are going 5 to 10 miles over the speed limit per hour in this area. So I'd say they're definitely speeding, right? So if I give this to you guys, record your number in an email sent by 30 employees. Start with 1 to 20 and do 6 intervals, okay? So what I would do is I'd pick my intervals. I'd say, okay, 1 to 20, 21 to 40, 40, I should make this way bigger. 41 to 60, and then I'd go like that, right? And I did the 6 intervals, and that's why there's 6 down here. 1, 2, 3, 4, 5, 6. Okay, and then I would count my numbers. I'd say, okay, how many of these are from 1 to 20? And I've got a 5 here, and I think in a 16, so that's where I'm getting the 2, right? So really it's just making a bar graph that represents the data, right? Now it says, which measure of center and variation would you use? So then I'm kind of drawing in my thing, and I'm saying, okay, well, this looks pretty much like a belt. It looks like a normal curve. So I would say my mean and standard deviation. We're going to talk more about what those really mean when we talk about our next section. So just letting you know, right? And explain, I would say, for explaining, I would say because it's symmetric. And it can be that easy, right? So now we can also do this when we have 2 data sets. We can say, okay, emotions of graphical symbols that represent facial expressions are used to convey a person's mood in a text message. So just emojis, right? Emoticons. The double distribution shows 2 groups, 1 female group and 1 male group. Compare the distributions. So this is just how often do people use emojis, right? So I can definitely say up here, I've got a pretty normal distribution, maybe slightly skewed, right? This one's slightly higher over here than it is. I would still probably say this is symmetric. So this one, I would say I would use for females. I would use mean and standard deviation because it's pretty symmetric, right? Now, if I'm using the guys, I can see that a lot less emojis are being used on the guys portion, right? So I can say, okay, well, this one I definitely need to push to the right to make make it more symmetric, more normal. So for the guys, I would definitely have to use the median and the 5-number summary. Okay, so for this one, I would say symmetric, it's normal, and for this one, I would say skewed right. And that's why I'm using the median, right? So for this one, same thing, I would look at this and I'd say, okay, for explaining these distributions, it looks like professional football players, years of experience, like so how old or how many years do they actually play for the NFL? Looks like it's a little skewed. We have some people who are there for a really long time. A lot of the time I think that's kickers, right? Is that true, guys? Kickers are usually the ones that are in there longer. But typically 3 to 5 years or 6 to 8 years. So I definitely say this is skewed right because I need to push that to the right. Company employees experience in years. So if I'm just talking about like school or staff, say, okay, well, most of the time they're there for like 9 to 12 years and then they kind of move on to something new. But we do have some of those people who die out pretty fast or decide this is definitely not what I want. And we do have some people over here where this is something I love and I'm going to stick at it for my whole work career. So this I would say is more symmetric. So I'd say over here I would use the mean and the standard deviation. And here I would use the median and my 5-number summary. Right? Because it's skewed. Now, if they ask why, if they ask you to explain, that's when I would say skewed. This one I'm skewed to the right because I need to push it to the right. And this one I would say symmetric. So I'm not going to make it any of them where I'm like, oh man, they're slightly skewed. So you have to be really picky about it. If it looks symmetric or when you draw it out, just roughly, if it looks symmetric, say symmetric. If it's skewed, if it's obviously skewed to the right or obviously skewed to the left, that's when I'm looking for skewed left or right. But this is all you're going to have to do on your assignment. Right? Have a nice day, guys.